Okay, here's a quadratic transformation problem. So Abby created a quadratic function g by first stretching the function y equals x squared vertically by a factor of 5 and then translating 4 units to the left and 2 units up. Kaylin, on the other hand, created a quadratic function h by first translating the function y equals x squared 6 units right and down 5 units. And then she stretched it vertically by a factor of a quarter. Determine the coordinates of the vertex, both of those functions, and also determine the coordinates of the points where these functions intersect. So let's have a look to see what Abby did. Abby, in the much more, standard approach, stretched first. So vertically by a factor of 5. And then Abby then proceeded to translate that function with the stretch, of course, intact. So 4 units to the left, which is x plus 4, not minus 4, but plus 4, and 2 units up, giving giving Abby a vertex of minus 4 and 2. And we'll switch that label to h of x as well. So Abby called that h of x. Okay, Kaylin, on the other hand, translated first. So 6 units right, so that's our subtraction in terms of our horizontal translation, and down 5 units. And before we record our vertex, we got to keep in mind Kaylin also stretched this entire function by a factor of a quarter. So this entire function that we just wrote down has to get multiplied by a quarter. I think especially keeping in mind that minus 5 towards the end. So Kaylin's, I just realized I mixed up my labels here. Kaylin was h of x. This was supposed to be g of x. Fix that up. Labels are supposed to help, not be a hindrance. Anyway, h of x is going to be 1/4 times x minus 6 squared. Minus 5 over 4. So that gives Kaylin a vertex of 6 and minus 5 over 4. So let's have a look to see what happens when we graph those two functions on our graphing calculator. So we'll type in f1 of x is x squared. And Abby's function was a stretch of that basic quadratic, and of course 2 translations in there as well. And it was plus 4 and plus 2. And there's Abby's function. And notice we do have the correct vertex, which is promising. And Kaylin stretched after the fact, so we'll have to put brackets around all this business here. So basically we're going to translate f1 of x first. And that was 6 units to the right and down 5 units. And by putting the brackets in there, of course, that will translate first and then stretch. And that gives us Kaylin. Let me drag this out of the way. A vertex that looks like it's around 6 and minus 1 point something. So let's quickly verify that we have the correct vertex in our written work, of course, which for function f3 would be a minimum value. And bingo, we have the correct vertex. And I guess we could also do that for Abby, just to double check. We don't want to waste too much time. So analyze the minimum of f2, which of course is 4 and 2. Okay, so the last part of this question is we've verified all our written work is correct, and then we can proceed to determining the coordinates of the points of intersection. So of course what I want to avoid, since this is a paper 2 question, I really don't want to analytically solve this problem. And I guess incidentally we might as well label these things as A and B here as well, to be super organized. So it's probably not a bad idea to write down that you are trying to solve the equation g of x equals h of x. Get rid of that. Okay, and of course that would be pretty time consuming and a colossal waste of time in a paper 2 situation, because you'd have to set both of those expressions equal to each other and expand them all and get rid of fractions and quadratic formula. So let's not do that. It's a horrible idea. So let's maybe we'll close this, turn off F1. So we got less stuff to look at, and of course we can probably guess that our points of intersection are up in that second quadrant somewhere. So let's not guess, let's shrink our axes down. We can see one, and yes, hiding way up there is a second point of intersection. Okay, so let's actually find those points of intersection. I think using the geometry feature, since we're in a document here, and that's under points and lines. And of course I missed that the first time, so we'll hit escape. Try that again. That was under points and lines, and it was number 4, intersection points. And once we click on both of those functions, voila, we see our coordinates showing up on the screen, which now we just have to write down in our written work. Okay, so you notice I at least attempted to draw our system of equations. It somewhat looks like what that looks like. Anyway, so notice on an IB paper 2, it's always a good idea to sketch your system of equations and indicate that you found the points of intersection, and you're writing down those coordinates, which are, to wrap up, -6.73, 39.3, and -2.32. And +16.1. And please keep in mind we spared ourselves probably 10-15 minutes of algebra by taking advantage of our calculator.